Class 10, Chapter 1, Real Numbers, Module 3 and 4. Objectives. In this module, you will learn about revisiting irrational numbers and revisiting rational numbers and their decimal expansions. Dear students, last year, that is 9th class, we have studied about real numbers. So, real numbers are what? A collection of rational and irrational numbers. Okay, so in this module, you will learn about irrational numbers and also rational numbers. So, the first one is about irrational numbers, revisiting irrational numbers. Okay, now we know the irrational numbers. So, its decimal expansion is what? Non-terminating, non-repeating. Okay, we know the examples. Which are they? 1.01, 01, 001, 0001, etc. Okay, but some other irrational numbers also. Which are they? Root 2, root 3, pi, etc. So, listen carefully. The first one, we know what? Root 2 is irrational. We need to prove root 2 as irrational. Okay, so before that proof, starting what theorem is there? The theorem statement only. Okay, no need of that proof. So the theorem statement is, listen carefully students, let P be a prime number. Suppose 2 is a prime number, example is given here. Okay, so listen, let P be a prime number. If P divides A square, then P divides A also, where A is a positive integer. Suppose we can take the example. If 2 is a prime number, 2 divides 2 square. Instead of 2 square, you can put 4 square also. Okay, so 2 divides 2 square means when you divide 2 square is what? Yes, 4. When you divide 4 by 2, you get the remainder as 0. That is 2 divides 2 square. Then what? 2 divides 2 also. Or when you divide 2 by 2, the remainder as what we get? The remainder as 0 itself. Okay, so divides means when we divide one number by another number, if we get the remainder as 0, that is divisible. Okay, now listen carefully. Here the theorem once more. If P be a prime number, if P divides A square, then P divides A also, where A is any positive integer. Now our proof, that is important. You can by heart it or just listen carefully. It is very simple one. Prove that root 2 is irrational. We need to prove what? Root 2 is irrational. For that the proof or the solution, let us assume to the contrary. Contrary means what? It's opposite of that. Okay, we need to prove what? Root 2 is irrational. Its opposite is what? It is what? Rational. So we can assume that root 2 is irrational. So what is the definition of rational? Which can be written in the form P by Q, where P and Q are integers. So listen carefully. Since root 2 is rational, we can find integers R and S such that root 2 is equal to what? R by S. Instead of P by Q, what? R by S is here. Suppose R and S have a common factor other than 1. Suppose R and S have a common factor other than 1. We can take one example. Suppose a rational number 4 by 6. Okay, so 4 and 6 have a common factor other than 1. Which one is that? That is 2. Okay, so we can divide that 4 and 6 by that common factor 2. So what we get? 2 by 3. So when we divide 4 and 6 by the number 2, at last what we get? The simplest form? 2 by 3. Okay, so suppose R and S have a common factor other than 1, then we divide by the common factor to get to root 2 as A by B, where A and B are co-prime. So dear students, listen, when we consider the example 4 by 6, it has a common factor which one? 2. So we divide 4 and 6 by the common factor. Then what we get at last? The lowest form is 2 by 3. Where 2 and 3 we know they are prime numbers. So 2 and 3 have a common factor which one? only 1. Such numbers are called co-prime numbers. So here what root 2 is equal to a by b. First root 2 is a rational number which can be written in the form r by s. Now we divide r and s by the common factor. At last what we get, root 2 is equal to a by b, where a and b are co-prime. Co-prime means what? It have a common factor only 1. Now cross multiply. Root 2 into b or b root 2 is equal to a. Squaring on both sides, and when we rearrange it, what? Square b root 2 square become 2b square. Root 2 square, root 2 into root 2 become what? 2. B square is equal to a square. Now we can apply that theorem. What? 2 divides a square. Now then the theorem shows what? 2 divides a also. That is here 2b square is equal to a square. So 2 divides a square, then 2 divides which one also? A also. Okay, that means a is a multiple of 2. So we can write what? A is equal to 2c multiple of 2 for some integer c. Why we consider a is equal to 2c? Because we need to make b is also a factor as 2. Now substituting for a, the value of a is equal to 2c here in this form, that is a is equal to 2c, where 2 in this 2b square is equal to a square. So what we get? 2b square is equal to, instead of a square, what we put? 2c the whole square. So 2c the whole square become 4c square. That is 2b square is equal to 4c square. Lowest form is what? 2 and 4 cancel, remaining 1 2 only right side. So b square is equal to 2c square. Okay, this means that 2 divides b square, 2 divides which one also? B also. Therefore, a and b have at least 2 as a common factor. But this contradicts the fact that a and b have no common factor other than 1. That means what? We make a and b as a co-prime number. Since if it is a co-prime, it having a common factor only 1. But here what? One more common factor. What is that? 2. This contradiction has arisen because of our incorrect assumption that root 2 is what? A rational. So we assume what? Starting root 2 is rational. It is a contradiction. So we can conclude what? Root 2 is irrational. Now listen carefully. The same as root 3 is irrational, root 5 is irrational. Change only that number. Instead of 2, we need to put what? 3. If it is 5, put 5. Okay. Take the square of 5. 5 square become 25. If it is 3 square become what? 9, like that. So the second one is what? Proof of root 3. Okay. Now one root 5 is that exercise question completed as homework. So listen carefully, students. For the solution of root 3 is irrational, let us assume to the contrary that root 3 is rational. That is, we can find the integers a and b where b not equal to 0 such that root 3 is equal to a by b. So directly we make it in the form what? A by b, where a and b are co-prime numbers. So suppose a and b have a common factor, which one? If it is a co-prime number, only one factor, 1. Then we can divide by the common factor and assume that a and b are co-prime. Okay. Then other than 1, we divide it and make it in the form a by b, co-prime. Now cross multiply root 3b is equal to what? A. Then squaring 3b square is equal to a square. Therefore, what? A square divisible by 3, then a is also divisible by 3. So we can write a as a multiple of 3c. That is, a is equal to 3c. Now substituting that above, 3b square is equal to, instead of a what? 3c the whole square. That become what? 3b square is equal to 9c square. Now cancel 3 and 9. That become b square is equal to what? 3c square. This means b square is divisible by 3 and b is also divisible by 3. Therefore, a and b have at least 3 as a common factor. But this contradicts the fact that a and b are corpora. This contradiction has arisen because of our incorrect assumption that root 3 is rational. So we can conclude what root 3 is irrational. So listen carefully, students. This first one and second one proved root 2 irrational, root 3 irrational. Important one, that is 3-mark question. Okay, now the sub question of that, multiplication, division, addition, subtraction, etc. Okay, the sub question, listen. Show that 3 root 2 is rational. Same as what we consider, let us assume the contrary, that 3 root 2 is rational. Then we can find a coprime A and B such that 3 root 2 is equal to what? A by B. Now the method is the root containing terms on one side, all the others on the other side. So root containing term is which one? Root 2. So root 2 is equal to A by that 3 into is there. When you change that into right side, A by 3B. Okay. So root 2 is equal to A by 3B. Up to that step. Then listen. Since 3, A, B and B are integers, A by 3B is a rational number. So 3, A, B are integers. Then A by 3B is a rational number. We know rational numbers written in the form P by Q, where P and Q are integers. So what here? Root 2 is also rational. Listen, right side is what? Rational. So left side is also what? Rational. But this contradicts the fact that root 2 is irrational. So what? A by 3B is rational, so root 2 is also rational. This contradicts the fact that root 2 is irrational. So we conclude what? 3 root 2 is irrational. Okay. So we need to prove 3 root 2 is irrational. This is what? Along with 3 into root 2 is there. Next question, what? Division. That is 1 by root 2 is irrational. For that the solution, listen. Let us assume 1 by root 2 is irrational. See. So if it is rational, we can write in the form 1 by root 2 is equal to A by B. Now 1 by root 2 A by B. So root 2 is what? The reciprocal of that. What is B by A? So B by A is a rational number, implies root 2 is also a rational number. Left side is a rational, right side is also a rational. So which is a contradiction, means our assumption was wrong. Okay. So wrong one. So we can conclude what? 1 by root 2 is an irrational number. Now next question, prove that 6 plus root 2 is irrational. So solution, 6 plus root 2, we need to assume what? As a rational number. So we can write in the form what? A by B, where A and B are coprime. Here 6 plus root 2 is equal to A by B. Root containing term which one? Root 2 is equal to A by B minus 6. Now next what? Cross multiply. Root 2 is equal to A minus 6B by B. This shows A minus 6B by B is a rational number. So we know that root 2 is also a rational number. This contradiction has arisen because of the incorrect assumption what? 6 plus root 2 is irrational. So we can conclude what? 6 plus root 2 is irrational. Now next one, show that 5 minus root 3 is irrational. Before top 6 plus is there. Next what? 5 minus root 3 is irrational. So solution, let us assume same 5 minus root 3 is rational. That is, we can write in the form 5 minus root 3 is equal to A by B. So listen, in this is subtraction. So when we keep minus root 3 right side, along with that root 3 minus sign is there. So to avoid minus root 3, we can change minus root 3 to the right side, A by B to the left side. That is 5 minus A by B is equal to root 3. Rearranging this equation, what we get? A root 3 is equal to cross multiply 5B minus A by the whole divided by B. That is, since A and B are integers, we get 5 minus A by B is a rational. So what root 3 is also a rational number. Now this contradicts the fact that what root 3 is irrational. Then this contradiction has arisen because of our incorrect assumption that 5 minus root 3 is rational. So we conclude what 5 minus root 3 irrational. So same step for all the other questions. Okay, now the next one is very important one question. Prove that 3 plus 2 root 5 is irrational. So addition and also along with 2 root 5 is there. Now for the proof, let us assume that 3 plus 2 root 5 is a rational number. So we can write in the form a by b. So 3 plus 2 root 5 a by b, where a and b are coprime and b not equal to 0. Now solving 3 plus 2 root 5 is equal to a by b. We get what we get, which implies 2 root 5. Keep 2 root 5 on side. 3 to the other side. A by b minus 3. That is 2 root 5 is equal to a minus 3b by b. Now at last what root 5 is equal to a minus 3b by 2b. Now this shows a minus 3b by 2b is a rational number. But we know that root 5 is an irrational number. So it contradicts our assumption. Our assumption of 3 plus 2 root 5 is a rational number is incorrect. So we can conclude what 3 plus 2 root 5 is irrational number. Now the last exercise, very simple one is there. Okay, just we can discuss the remaining problems. We can work out the whiteboard also. Okay, revisiting rational numbers and their decimal expansion. So listen carefully, students. Rational numbers. What do you mean by rational numbers? Yes, collection of numbers which can be written in the form p by q. So rational numbers are two types. One is terminating, other one is non-terminating repeating. Here we need to find out the condition of rational numbers and irrational numbers. Okay, so here let us consider the following rational numbers: 0.375, 0.105, 0.875. So all these are what? After some places of decimal, the division stops. So such rational numbers are what? Terminating rational numbers. So the condition for the terminating rational number is the in this exercise. Okay, so 0.375 is equal to 375 by 10 cube. So 3 into 5 cube by 2 cube into 5 cube is equal to 3 by 2 cube. Then 0.104, that is 104 by 10 cube. Then we can find out the prime factors, that is 13 into 2 cube by 10 cube is what? 2 cube into 5 cube, 13 by 5 cube. Now the last one example, what? 0.80875. So 875 divided by 0.14, 10 raised to 4. So that is what, when we find out the 875 prime factorization, cancel all these numbers. At last we get what? 875 by 10 raised to 4. That is equal to, when we find out the prime factorization and cancelled, at last what we get? 7 by 2 raised to 4 into 5. Now the conditions, listen carefully. Let x is equal to b by q be a rational number such that the prime factorization of q is of the form 2 raised to n and 5 raised to m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. Okay, that is what example 0.375, the decimal expansion terminates. Same as 0.104, 0.0875. The next one, what? Some other example, 1 by 3. What is 0.333, etc. Or we can write what? 0.3 bar. Same as 1 by 7, 0.142857, 1428571, etc. Okay, So that number is what? Repeating. So the theorem, let x is equal to p by q, where p and q are coprimes, p a prime numbers, such that the prime factorization of q is not of the form 2 raised to n into 5 raised to n. Listen carefully here, 1 by 3 and 1 by 7. The denominators q are not in the powers of 2 raised to m and 5 raised to n, where n and m are non-negative integers. Such a type of decimal expansion what? Non-terminating, repeating or recurring. Now from the above discussion, we can conclude that the decimal expansion of every rational number is either terminating or non-terminating, repeating. Okay, so listen carefully. These are the two theorems. The statement only you need to by heart. Okay. Then the last question. The following real numbers have a decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factorization of q? So the three numbers are given. First one, listen carefully when you consider 43.1, 2, 3, 4, 5, 6, 7. It is what type of numbers? Which is what? A terminating rational number. So listen carefully here. 43.1, 2, 3, 4, 5, 6, 7, 8, 9. So after some place of decimal, the division stops there. Now it can be written in the form. Avoid the decimal. That number divided by how many decimal places are there? Put 1 and along with that series. That is what? That number divided by 10 raised to 9. So 10 can be written as what? The powers of 2 and 5. So if the denominators are the powers of 2 and 5, that is what? Terminating rational numbers. Okay. Now the conclusion, this is in the form p by q, and the prime factors q are the powers of what? 2 and 5. Second one, when we consider 1.120, 1200, etc. So we know, we are very familiar with that. So what type of a number is that? An irrational number. Clear? Now what about the last number? 43.1, 2, 3, 4, 5, 6, 7, 8, 9, etc. That is what? That number is a non-terminating, repeating number is. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is a repeating. So that is also a rational numbers. And if it is a rational number, what can you say about that? Denominators of power, they are not in the powers of 2 and 5. Clear, students? Okay, some other questions also we can work out the problems in the whiteboard. Okay, thank you.